All right, our next speaker is a badass who was in the guts of the Xbox. Robert has worked on Xbox One, Xbox 360, not just peripheral stuff, but going into boot firmware and all these hardcore things. I don't even know what they fucking mean. But I actually know Robert better as a fellow American who has moved down here to New Zealand and made Wellington home. I know him as someone I can count on to see at Wellingtaru and other events and share a beer, and someone that I'm overdue for a round of magic with. So, coming up here, please welcome him and the luxurious beard he brings, worthy of a lumberjack, not just the hipsters in Seattle where Microsoft comes from. It's Robert Francis! Ow.
Welcome, everyone. So let's go ahead and get started. Oh, whoops. That was wrong. There we go. Welcome to How Did They Ship With That? My name is Robert Francis. I'm a principal software engineering manager at Xbox, which is part of Microsoft. Some people don't know that. A little intro about me. I lead the Xbox core operating system team. I've been on some form of the Xbox platform team for the last 14 years. I moved to New Zealand just over 2.5 years ago with my family, where I continue to lead my team at Xbox remotely from my living room in Lower Hutt. Yes, adjusting to Seattle time zones, which is fun doing 4 times a year. And then obligatory family photo to show that I am indeed a real human. This is my family at the Korokoro Dam this last summer. So brief history of my career. I joined Xbox in 2012. I started off by helping porting media apps to the Xbox 360, then helped write setup UI for the Xbox One launch. So if you set up an Xbox One, you got to go through some menus I wrote. Then I was a founding member of the Backward Compatibility team, making Xbox 360 games run on the Xbox One. I wrote emulation code for the file system, audio decode and playback, input, and I own the end-to-end build system, ingestion and publishing tooling to take any arbitrary 360 game, get it into our build system, build it, and then publish it into the store, which was hundreds of games and DLC. Then in 2018, I got asked to help Xbox Cloud start Xbox Cloud Gaming, where I made my career transition to being a manager. I led the Xbox server team, customizing the Xbox hardware and software to run in a data center environment, and I led that team for 6 years. Then in March of 2024, I took over leading the Xbox core operating system team, where I now focus mostly on our next generation console, which we publicly announced a couple months ago as Project Helix. As you can see, I've spent a large part of my career making it so that games run in places that they weren't coded for and definitely weren't tested for. So in that time, I've seen some things. I've seen games do a lot of strange things. I'm going to go over a few of the more memorable things that I've seen and call out some lessons that hopefully you all can learn from. Or you can just enjoy some slides with memes and silly stories. Just as a side note, because this talk is being recorded, I am not going to be naming games specifically, but I will be available after chat and be around all day. So if you have burning questions about individual titles, I'll spill the tea, but I'm not going to do it while the recording is going. Anyways, first up, async is hard. We started off by getting some reports from users in Xbox Cloud Gaming that were in Europe that a particular game rendered a black screen for 5 minutes after the game started up, after it was launched. We looked into it, and it was every time they played. We looked into it, and it turned out that the game was doing 100 DLC ownership checks every time it started up, and each of those ownership checks was serialized and took 3 seconds to get to the licensing servers in the US. So 300 seconds, bam, 5 minutes. So that was the problem. Now, on cloud gaming, we wanted the promise of if you owned any piece of DLC you owned, you could use in the game that you launched. And so we had every piece of DLC installed on the server, whether you owned it or not. This game saw all of those and was like, cool, license check this user. I'm going to check if you own all of this DLC. And it's like 1 out of 100 5 minutes later. So on local consoles, those licenses would actually be cached. And so those checks would be near instant because and you only had usually what you installed, what you owned. So this didn't happen on local consoles. On cloud, every user looked like a new user every time. So it was like, do you own all these every single time? So the fix was we, on the services side, would pre-check what the user owned and then send a list to the server when it was being set up to ensure that the game only saw what we already knew that the user owned. Another game had some similar problems, and it would actually time out and crash, and so the user actually never got into gameplay. So fixing that actually fixed that one too. That's another lesson. Most games, there's rarely does one game do something bad. It's usually a bunch of games do the same thing bad. Next up, we had a game developer that contacted Xbox Live because they were getting reports from their users that they all of a sudden were experiencing a huge FPS drop. And this was weird because it didn't correlate with an OS update nor a game update. It just happened. Turns out that the correlation that had happened was that Xbox had rolled out a per console throttle to Xbox Live because there was a lot of misbehaving games that were coded and spamming Xbox Live and accidentally DDoSing it. So this throttle caused the game's FPS to tank. So yes, the game had a call to Xbox Live that they waited on every frame on the same thread as they're rendering. So fix on this one, kind of straightforward, told the game, patch your game and cache the results. So lessons here. Keep your game responsive during asynchronous calls. Cache results, especially if they don't change. And definitely don't put async calls in the render thread, especially when they go over network. Next up, not all hardware is the same. When doing Xbox 360 back in Pat, we had to convert PowerPC assembly instructions into x64 assembly instructions. This is literally like the language the CPU runs. We ran into a crash in the emulated code when it was trying to access an incorrectly calculated memory location. Some background on the Xbox 360 CPU. It had really good performance in doing vector math. So vectors are 4 floating point numbers. You use them for points and all sorts, points in space and all that stuff. And so math of cross products and dot products and matrix math is always really good to have that be done fast. And so 360 had CPU instructions for doing this and doing it fast. And doing that one vector instruction on four floats was faster than doing a similar calculation with 4 integers. So some developers would do their integer math with the vector calculations instead, including memory address calculations, and including this game. So this had a precision problem in our emulator because of how the 360 CPU calculated floating points. It actually went to 24-bit precision instead of 32. And we emulated the floating point calculations for performance. So enough games did this in a short time window that we hypothesized that there had to have been like a GDC talk that said, here's how you get some extra performance. You do some memory address calculations using floating point numbers. We couldn't find an actual talk to point to cite the blame, but that was our hypothesis. In the end, we added an emulator flag where we could tag individual functions and say, nope, we're doing exact precision floating point emulation on here instead of performance. Next one was another 360 emulation bug. We ran into a game that had some really weird visual artifacts. Not this one. This is a random game I pulled off the internet, and it's a PlayStation game, so it's not even related at all. Turns out that the game was reading past game shader was reading past the texture limits. And so, for those that don't know, typically when you're reading a texture from a shader, you read between 0 and 1 on both the X and Y axis. This game was going above and below those numbers because it realized that the 360 hardware would actually wrap it for it. So reading from 1.1 became 0.1, and reading from negative 0.1 became 0.9. This was undocumented behavior on the Xbox 360 because it was undocumented behavior on the Xbox 360, so of course the Xbox One didn't adhere to it. So the fix was we ended up patching that game and rewrote the game shader to do its own clamping, but maintain the logic it was trying to accomplish. So lessons here. Your game might eventually run on hardware that you didn't test it on, so Try to avoid using undocumented hardware hacks because they're not promised to be maintained moving forward. And avoid having designs that depend on bit-precise floating point math. That's also just a good thing in general not to do. And these two tips are actually more prevalent than ever. For those that don't know, ARM gaming is growing, especially on PCs. You can buy a Windows ARM PC and play x64 games on it. It is all emulated by the operating system and converted just in time. And similarly, Steam's upcoming VR headset does this one better. It will play your Windows x64 game on ARM on Linux. So, so you publish your Windows game to Steam and it will play on ARM on Linux because of everyone doing this work underneath you. So, so it is kind of important. Lastly, and most importantly, don't implement everything you hear at conferences, with some exceptions. Okay, this next story is about multi-threaded programming, which is always super easy and very engaging to cover as a topic in a PowerPoint presentation. I've tried to make it interesting, but since I'm a programmer by trade, I'm legally obligated to include box diagrams. So here we go. And for those of you that you can all feel free to take a nap, I'll wake you up at the end of it. Okay, so in the early days of 360 Back Compat, we had a game that was randomly freezing and during gameplay. We debugged it and saw that the freeze was in the main game thread because the actual thread was suspended, so it wasn't running. And then we saw another worker thread that was running, but it was looking for work that it didn't have, so it was just checking, doing nothing, checking, doing nothing. We also saw between these two references to some shared memory for a job list that was empty. And it's like, huh, that's kind of weird. So some context for some folks. A pretty standard problem when doing multi-threaded programming is shared data. And you need to make sure that the data stays sane between the two threads, not allowing multiple threads to read and write at the same time. Otherwise, you risk that you get half-written data by both, or data is in the middle of being written when it's read. And so you need to make sure that at any given state, one thread can access data that is actually complete. It's like stopping someone in the middle of a sentence and expecting it to make sense. There's a number of ways to work around this. It's pretty standard. A pretty standard one is using a lock. You start by creating a lock for the data. Then whenever the main game thread wants to access the data, it acquires the lock, it accesses the data, releases the lock. And then conversely, when the worker thread wants to do the same thing, it does the same thing. So it acquires the lock, accesses the data, releases the lock. Kind of pretty standard. For non-programmers, this is like in real life. If you have a roommate, a flatmate, excuse me, and a kitchen that's only big enough for one of you to use at a time, if you want to use it, you would, and you see it's empty, you would call dibs really loudly. You would use it, and then announce to your roommate, to your flatmate when you're done. But when you use it, your roommate is awake. If they happen to need the kitchen, they'll wait for you to finish what you're doing, or maybe they'll work and sleep until you're done. Pretty straightforward. So what was this game using to protect its shared data? Semaphore, mutex, critical section, or another similar API that's been available to solve these problems since 1993. This game came out in 2008, so surely it was using one of these well-documented solutions, right? Well, no, you saw what talk this was. And I'm not like I'm going to change the talk halfway through to as a curveball. So nope. When this game's main thread wanted to access the shared data, job data, it called suspend thread on the other worker thread. It accessed the shared data, and then it called resume thread on the worker thread. Similarly, when the worker thread, most importantly, wanted to access the game data, you could see what it did. It called suspend thread on the main game thread. It accessed the data, and then resumed the main game thread. I saw some groans and some hands on heads. So for going back to our roommate analogy, or flatmate analogy, This is like if you wanted to use the kitchen, but you don't actually want to talk to your flatmates, which I've definitely had some of those, and maybe some people in this room can relate. So instead, you run up to them and you knock them out. So you then have the kitchen all to yourself. They won't get any work done in the meantime, but they definitely won't be in the kitchen. It works, but only if nothing needs your roommate to be conscious to be done during that time, like a work emergency or someone depending on them finishing their current task on time. Pretty heavy-handed implementation, right? Well, it worked on the 360, so that means we had a bug in our emulator. So remember when I said async is hard? Well, it turns out on the 360, the call to suspend thread was a synchronous call. The API only returned after the target thread had been suspended and is no longer running. The version of suspend thread on the Xbox One, asynchronous. So that means what we were seeing was worker thread makes a call to suspend the main game thread. Worker thread accesses the data. Worker thread calls resume. Main game thread is running through that entire time, and the original suspend thread call hasn't even completed yet. And so you're calling resume thread on a currently running thread, which is a no-op. The original suspend thread finishes, the main game thread is suspended, and is permanently frozen because it's no longer dispatching work for the worker thread to then call resume on it again. So how did we patch this? We didn't. We made the emulators call to suspend thread synchronous to match the Xbox 360, and the game's hacky behavior continued onward, and if you still own this game, it is still playable on Xbox One and Series consoles today. So, some lessons here. Typically, you want to follow best practices when it comes to solving common problems. They tend to be best practices for a reason. And next is to use APIs for their documented purposes. Otherwise, you risk taking a dependency on behavior that isn't guaranteed. That said, giving some credit to the game that I was talking about here, the documentation on suspend thread has gotten better. The 360 documentation had this soft wording of not particularly useful for synchronization, whereas the current Windows documentation for the same API explicitly says it's not intended for synchronization and warns that this pattern could lead to a deadlock, which is also what we call when all of your threads are suspended and no longer running. So, phew. Okay, everyone that took a nice nap on thread synchronization, you can wake up now. We're past that. We're over the hill. And now we're all done with the fun box diagrams, and now we're going to get back to some memes. Next up, mouse and keyboard versus controller. So on Xbox Cloud Gaming, we added support for keyboard and mouse, and a new game was coming out that advertised, hey, we support keyboard and mouse. And then as soon as it launched, we were getting complaints from users that says, no, it doesn't. Looked into it, and turns out that this particular game, in order to make it run with mouse and keyboard, you had to navigate to a menu with a gamepad and click Enable Mouse and Keyboard. So luckily, this game had just come out. Developers were still patching it, which is not a guarantee in my field. And the fix was just ask them to police politely not require a gamepad in order to enable non-gamepad. So next, on Xbox Cloud Gaming, when we were trying to light up the mouse and keyboard support, we noticed that there was a certain set of games that didn't work with mouse and keyboard on cloud, but did on local console. So we dug in and saw, okay. We dug in and we saw that these games actually required these devices to be plugged in prior to the game starting in order for the game to then realize that they were there and be able to use them. It's like, okay, cool, we can make a change to our code and logic to have the virtual version of these devices always plugged in when the game starts. That's pretty straightforward. So we do that. Now we see another category of games with a set of bugs that just lit up, where the game always renders an in-game cursor. It's like, huh, okay. So, and that's all if the mouse is detected. So we're like, okay, well, how about we change our logic to only attach the mouse and keyboard when the user decides to start using them. Okay, cool. So the virtual devices only get added when there's intent. Well, now we're back to problem one. So we as a platform are like, how do we solve a problem where the solution breaks another set of games? Well, we ended up having a per game server configuration that would set what behavior we wanted to have happen when the game was being set up to play a specific game. And that's what we ended up launching with. So sometimes in the platform side, these are called quirks, where you have very specific bug fixes only for these things that need them because fixing it holistically would break too many other things. So what's the lesson here? If you're supporting mouse and keyboard and gamepad in your game, keep it simple. Listen for input events and swap the logic and UX to match the most recently used input device of the event. And this is, that's it. No fancy device detection, nothing like that. Just look at events, swap, do it. Okay. This is actual guidance that Xbox gives in its official docs, and most games are adhering to that nowadays, so you usually see pretty good behaviors now. Next up, data location matters. In early Xbox Cloud Gaming, users would play a game and they would see tutorial text every time they played the game, even though they completed the tutorial, and this didn't happen on the local console. And this was because the game was saving the I completed the tutorial flag in local save data, which at the time on Cloud Gaming, we didn't roam that between cloud sessions. So this ended up being like, that local data ended up being decently player impacting, so we started roaming it, and a lot more games took advantage of this. Fallout, Skyrim put their mods there. Flight Sim put all of your downloaded content there, so it ended up being not the only game that had player impacting info there, so we just roamed it. Next up, user reported that a game was super washed out when they're playing on cloud gaming, but looked fine on their local console. Debugging it revealed that the HDR brightness settings were saved to the game's saved game file. For those unaware, HDR is a TV feature that allows more data to have better color and more vibrant colors to be used versus SDR, which is the standard version. And so you get more nuanced brightness and colors, but you need more data for it. Cloud Gaming only supported SDR, and so the game applied the HDR brightness to the SDR image and made it super washed out. The kicker, the game even knew that it was running in SDR mode, and therefore in the settings you couldn't change the HDR brightness. So you had to go back to your local console to lower your brightness. So the fix was another one where the game developer had to patch it, and then it was all good. So lessons here. Again, pretty straightforward on this one. Put game data, including tutorial completion flags, in the game save file, and put local hardware settings / configs in a local file. Don't migrate, don't roam them. So, what are the main takeaways from this talk? I could say async is still very hard, and you need to read the docs, but nah, there was some better takeaways from this, right? There we go. So, every bug and flaw that I talked about today was in a game that sold millions of copies. Users can't see imperfections, and the imperfections that they can see, they will put up with, they tend to put up with a lot if the game is fun. So remember that game that I talked about that had 5 minutes of black at the start of it? Even when that bug was still reproducing, it was the #1 played game on Xbox Cloud Gaming at that time. So remember, perfection is the enemy of good enough. And one thing that I've learned while living here in New Zealand is that Kiwis love hacky solutions that work good enough. So with that, my final lesson for you all is embrace your Kiwi ingenuity, accept that you'll make mistakes on the way to good enough, and realize the only thing worse than shipping with bugs is not shipping at all. So it doesn't matter if your game code is shit as long as it's fun, so go make fun shit.
Hi, Robert.
Hi.
Thanks for the talk. I love hearing your stories. I just wanted to ask if there was any, you don't have to name names, any truly cursed game that you just failed to port.
On what, the 360?
Yeah.
So here's the funny thing is that we had a lot of really, really smart people on that, and any game that was a problem was just the challenge. There was some games that like a developer worked on for 6 months. But then They ended up, it ended up just being whatever the reverse of death by 1,000 cuts is. They ended up just like little solve, little solve, little solve, little solve, and then that ended up accruing value to like a bunch of other games. And so by the time of just working through those gnarly ones, it ended up being accruing value everywhere. So like I said, it's very rare that one game does something uniquely bad for itself. It's usually like classes of issues shared all over. So most of the 360 games that didn't come over was because of licensing problems.
Thanks. How many person years did your back-compat team spend on this project, roughly?
On what, the 360 games on Xbox One? I think at its peak, we probably had like 25 engineers working full-time for 2.5 years, and then a huge QA team. And it was like, there was waves of games that would come out. So like, I think we worked a year, and then we got our first like 10 titles, and then had to crunch and get like 100 out, and then we kept putting waves of more and more out. And then eventually it just turned into test, turn crank, bug fix, tweak, and then it turned into a point where it was mostly just configuration on per title and then test cost. Okay. Oh, yeah, there we go.
Hey, so some of these issues seem like just insanely specific. What is, and like for such a long and wide variety of games, what is your approach to even find the cause of these, and like how do you go about actually discovering what is going on?
You have to start with the baseline that, and you have to go verify this, that it worked on the thing that it originally was coded for. So you go double check if it works over there. Then you go look at YouTube to see if this was just a lower chance thing that happened on original hardware that is now like a higher chance on yours. And once you've eliminated those two things, you then have to just start digging. And it's like, what type of issue is this? Like, it's related to this, so that means, like, there's a surface area that we as the platform provide of APIs. Some behavior there changed. What changed? And so the issue will give you a hint about what area is potentially the cause, and so then you start going and looking, and you inevitably you have to go break out a debugger and attach to a game that you have no symbols or source code for, so you're doing assembly debugging and looking at platform calls and trying to deduce behavior and yada yada. And so that's why it would take like 6 months, because we had some people on the team that would literally do this black box debugging and be building up like a beautiful mind like graph of how the game was constructed on their whiteboard to try and figure out how what was going wrong.
I always imagined that the Xbox 360 and the Xbox One would have been kind of very similar architecturally, but what are the major differences?
All of it. Brand new operating system. The CPU, completely different assembly instruction set. GPU, completely different. Still made by AMD, but many generations later. So speaking different languages, different shader models. Hard drive, still spinning hard drives. So, but the 360, a lot of games were played off of disks still, and none were actually played directly off disks on the Xbox One. It was just a license check. So, yeah, all of it.
Sorry, so did the Xbox 360 not use x86?
No, it was PowerPC.
Huh.
Yeah, it's a different assembly instruction language. It's the same thing as like old Macs before they went to x64 and then to ARM.
Hi, so given there's a significant amount of time between the 360 and the Xbox One,
Yeah.
I'm imagining some studios potentially went under in between.
Oh, yeah.
Yeah. So how many games did you actually have like source code for, or how many did you have to decompile yourselves, or?
None of them had source code. We never got source code from any of them.
Oh my
We
fucking
got
God.
symbols from a handful, which then at least gave you hints about what the names of the functions were that were potentially failing. But no, we got
Oh my God.
we got source code from none of them. It was just the direct binaries that they shipped, and sometimes we got symbols.
Do you think that'll change in the future, maybe?
No. But that's also why everything is now x64.
Thank you.
Time for one more.
So this is maybe a bit similar to the last question, but back in the past, I guess a lot of games were made like specifically for hardware,
Yep.
not using engines like Unity and stuff, and that's a bit more common now. And so I guess the things are made a bit more like higher level, more abstractly. So does this happen less now or more somehow?
You now are at the whim of the engine doing it for you in a lot of cases. But then some of these practices, like where you save game data and things like that, you're still in plenty of control to shoot your foot. And also writing your own shaders, things like that. So.
Right. Yeah.
And even in those game engines, you can dig in and get licenses to modify things at a lower level and go platform specific if you want to.
So it still happens a lot?
Yeah. It's whatever's easy, like easy and fast. And not knocking it. That's the whole point of the talk. Okay.
All right, find him outside so we can